Hello, and welcome to Boot Camp, Unit 12C, Volume and Surface Area. We've been talking in the past two modules about finding area, and we can do that now, but what we really need to find now is the volume and the surface area of shapes. The volume of a shape is how much it can hold. If the area is just a 2D figure, when we take this now to 3D, or in 3 dimensions, we need to figure out how much it can hold. Taking a look at this shape here, we have a cube, a little gift box. The surface area is how much wrapping paper we'll need to cover this box if we're going to give it to somebody for their birthday. To find surface area, all we have to do is add up the area of every side of this shape. In this case, this is a cube, so we have to add up all of these little squares. How many squares are there? There's the front, there's the back, there's the side, there's the other side, there's the top, and there's the bottom. So we can go through and add all these up, or because they're all the same, we can just multiply one of the sides by 6. This is a square. So the area of that square will be length times width, or 4 times 4, which is 16, times 6, which is 96. On the right, you see a little pyramid. Without going through all the detail right now, we have the bottom, which is a rectangle, and we have 4 triangles, one on either side. The triangles have an area of 1/2 base height, the height here being 8, and the base being 4. 8 times 4 is 32, divided by 2 is 16. So each of those 4 triangles have an area of 16, and the bottom has an area of 16. Add those all up and you'll get the surface area of our little pyramid. Moving on to volume. If surface area is how much wrapping paper we need, volume is just how much we can cram into these shapes. The formula for volume that we're going to follow is that the volume is the big base times the height, the area of the base times the height. Looking on the left here, we have our cube again. What shape would we recently think is on the bottom here? It's a square. The area of that square, length times width, 4 times 4 is 16. The height of our cube is 4, which gives us a volume of 64. It is worth noting that because we're doing this in 3 dimensions, we will be using what are called cubic units. You'll often say cubic feet, cubic inches, cubic miles, if you hear this in the practical world. On the right, we have a cylinder. And the same formula applies. It's the area of the base times the height. In this case, what shape is the bottom? It's a circle with area equals pi r squared. If it has a radius of 3, then the area is 3 squared, 9 times pi, or 9 pi. Multiplying that by the height, 7, we get 63 pi cubic units as the full volume. Now we have things that come to a sharp point. What are we going to do now? We have our little safety cones on the left, and we have our pyramids. Well, if you take a look, we can basically turn our cones into cylinders, and there are about 3 identical cones in there. The volume for things that come to a sharp point is the area of the base times the height, times 1/3. 1/3 base height. In this case, we have our little cylinder. We figured out from the past that we had 63 pi for our whole cylinder. So the volume of just that little cone would be 63 pi divided by 3, otherwise known as 21 pi. Pyramids have the exact same kind of computation. That is a very, very brief look at volume and surface area.